In this video we're going to work with automatic number plate recognition, and this is exactly what you will be able to do with today's tutorial. You can see that we're detecting all the license plates in this video, and we're also reading the text from these license plates. We're using 100% Python, we're going to use an object detector based on Yolov8, we are going to do object tracking, and we're going to read the text from these license plates using EasyOCR. So this will be an amazing tutorial. My name is Felipe, welcome to my channel, and now let's get started. So let's get started with this tutorial. Today we are going to work with automatic number plate recognition, and let me show you a few resources, a few repositories which are going to be super useful for today's tutorial. The first one is Yolov8, because we are going to be detecting license plates and then we're going to be reading the text from the license plates, right? And in order to detect our license plates, we are going to use an object detector which is based on Yolov8. So Yolov8 is going to be super important in today's tutorial, and I'm going to show you more details in a few minutes. But for now, let me show you the other repository which we are also going to use in this tutorial, and it's going to be super important, and it's SORT. It's an object tracking algorithm which is called SORT, because today we're going to do object detection and we're also going to do object tracking. This is going to be an amazing tutorial, and in order to do object tracking we are going to use SORT. And then once we have detected the license plates, once we have implemented all the object tracking, once we have done everything we need to do, we are going to read the content of the license plates using EasyOCR. So this is a Python library which is going to be super important in this tutorial. And now let me show you the data we are going to use in this tutorial. Let me show you the video we are going to use in order to test the automatic license plate recognition software we are going to use in this tutorial. You can see that this is a video of a highway, and we have many cars which are going through this highway. And the important thing about this video is that all the cars, we have like a very frontal view of absolutely all the cars, and most importantly we have a very frontal view of all the license plates, right? You can see that for absolutely every license plate we detect in this video, we have a very frontal view, and this is an ideal point of view to build a project like this. So this is exactly the video we are going to use in this project. And now let me show you something else. If I go to Google and I search for license plate and I go to images, let me show you something. You can see that we have a lot of diversity when it comes to license plates, right? We have many different types of license plates. We have some license plates which are comprised only with numbers, like this one. Then we have other license plates which are only letters, like these two. And we have many different examples. We have many different types, many different formats. I will say that absolutely every single country, absolutely every single state, absolutely every single time in history have its own license plate format, right? Its own license plate style, its own license plate system, right? There are many different types of license plates. There's a lot of diversity when it comes to license plates, and obviously that it's very challenging to build an automatic license plate recognition software to deal with absolutely every single type of license plate, right? I'm not going to say it's impossible. It's not impossible, but it's a very challenging task. So in order to make it more simple, in order to simplify our problem, we are going to focus only on one very specific type of license plate, which is this one. We are going to be working with the United Kingdom license plate system, with the United Kingdom license plate format, which is comprised of 7 characters. The first 2 characters are letters, then we have 2 numbers, and then we have 3 more letters, right? So we have 2 letters, 2 numbers, and 3 letters, and this is the exact structure of the license plate type we are going to be working today in this tutorial, right? This is the exact same type we are going to be detecting with the software we are going to build in this tutorial. But today I'm going to show you a very generic process and a very generic pipeline. So by making some adjustments into the code we are going to be making today, you will be able to apply the same process to other types of license plates, right? We are going to work with this type in this project, but you will be able to make some adjustments in everything we're going to be doing today, so you will be able to apply the same process to other types of license plates, right? So that's something I'm going to show you better in a few minutes, but for now let's continue. Now let me show you something else. When we were starting this tutorial, I showed you that we were going to use an object detector based on Yolov8 to detect license plates. Now let me show you the data I used in order to train this license plate detector, right? This is exactly the dataset I used in order to train this detector. And I'm going to give you a link to this dataset in the description of this video. And if you want to know exactly how I trained this object detector, I invite you to take a look at one of my previous videos where I show you how I trained an object detector using Yolov8. In that video is the step-by-step guide of how to train an object detector using Yolov8, and that's exactly the same process I followed when I was creating this license plate detector. So this is the data I used, and if you want to know exactly how I trained that object detector, then just take a look at the video I'm going to be posting over there, right? So now let's continue. I already showed you all the resources we were going to use in this tutorial. I already showed you the type of license plate we are going to be detecting today, and now it's time to go to PyCharm so we can start implementing all the code of today's tutorial. And now let's go to PyCharm. Let's go to this PyCharm project and let me show you some files I have over here. You can see I have many different files, and for now let's just focus on these two, main.py and util.py. Main.py is the file in which we are going to be coding the entire pipeline of this tutorial, right? You can see that this is a sequence of steps which we are going to follow in order to build this automatic license plate recognition software. You can see that the first step is loading the models, then loading the video, then we're going to read frames, and so on. This is the entire pipeline, the entire process we are going to be building today. And then we have this other file, which is util.py. In this utils file, we have 5 functions. Let me show you. These are the functions we have defined over here. And from all of these functions, we are going to focus on these two, which are read license plate and get car. These functions, if I open these functions, you can see that they are completely empty, right? We need to implement these functions in this video, and then the other 3 functions, they are already implemented, right? Everything is ready and we're just going to use them. And the idea is to focus on these 2 functions over here because these 2 functions are way more important from a computer vision point of view, right? So these are the functions we are going to focus the most, and this is the util.py file. Now, if I go back to main.py, now it's time we start with this process. Now it's time we start with this pipeline. And in order to do so, we are going to start importing YOLO. So I'm going to say from Ultralytics, import YOLO. And then we are going to load the models. That's the first step in this process. And the interesting part is that we are going to have 2 models because we are going to be detecting license plates, but we are also going to be detecting cars. That's going to be a very important part in this process. So I'm going to be loading 2 models. I'm going to call the first one of these 2 models Coco model because this is a model which was trained on the Coco dataset. And this is going to be YOLO, and we're only going to use a pre-trained model from Yolov8, which is Yolov8 nano.pt, right? We are just going to call this pre-trained model, and this one we are going to use in order to detect cars. It's very important we detect cars. I know we are going to detect the license plates and we are going to read license plates, but detecting cars is going to be super important, and you're going to see exactly why in a few minutes. Then we're also going to load the license plate detector, and we're going to call it license plate detector. And this is going to be YOLO, and we need to input the path to this license plate detector, and the license plate detector is located in a directory which is called models and is called license plate detector.pt. So I'm just going to models. Okay, now it's time to load the video we are going to use today, and in order to do so I'm going to import CV2, and I'm going to call CV2 video capture, and I'm going to input the video location, which is something like the current directory, and it's called sample.mp4. Okay, and this is going to be cap. Okay, now we are going to read frames from the video, so I'm going to define a variable which is read, and I'm going to initialize it as true, and then while read I'm going to read frames from the video like this. Read frame equal to cap.read. If read, then I'm going to continue. Okay. And this is going to be pretty much all for now. So we are reading frames from the video, and now it's time to continue detecting all the vehicles, right? We are going to be detecting all the cars, and therefore we are going to be detecting the vehicles. And in order to do so, this is where we are going to use the first model, which is the model trained on the COCO dataset. So we are going to do something like this. I'm going to call COCO model, and I'm going to input the frame, and this is going to be results, right? I'm going to call this object detections, and in order to move one step at a time, I need to access the first element, and in order to input one step at a time, I'm going to print detections, and I'm only going to execute the first 10 frames, otherwise this is going to be very this is going to take a lot of time. So and frame number lesser than 10, and obviously I need to define a variable which is frame number. I'm going to initialize it in -1, and then I'm just going to increment it here. Okay, and I don't really need the pass anymore, and let's see what happens if I print detections. Okay, so everything seems to be working just fine. This is all we got. And you can see that this is a lot of information. These are all of our detections. So everything seems to be working just fine. So what I'm going to do now is we are going to iterate for detection in detections. And this is going to be for detections.boxes.data.toList. And let's print detection again, so we know exactly how this looks like, and we know how to access all the information. Okay, so this is how each one of our detections looks like, right? You can see that we have 1, 2, 3, 4, 5, 6 numbers, and the way this works, this is going to be something like x1, y1, x2, y2. Then we will have the score, and then we will have the class ID, right? This is detection. So remember, we are using a model which was trained on the COCO dataset, so we are detecting many different objects, right? This is the class ID. This is exactly the type of object we are detecting at every single time, at every single one of these detections. So this is very important. And then we have the confidence value, right? This is how confident our object detector is of this specific detection, and then this is the bounding box, right? So we have x1, y1, x2, y2, the bounding box, then the confidence score, and then the class ID. And something that's very important, we are doing all of this in order to detect vehicles. So as the COCO dataset, as this model which was trained on the COCO dataset is detecting many different objects, we are going to say something like this: if int class ID in vehicles, then we are going to continue. And vehicles is a variable which we haven't defined, and we are going to define it with the indexes, with the class IDs of all the vehicles in the COCO dataset. This is a list of all the objects which we can detect using this model, right? You can see that these are a lot of objects, and some of these objects are related to vehicles and some other objects are not. For example, you can see we have person, bicycle, car, motorbike, airplane, bus, train, truck, and so on, right? So from all this very long and very comprehensive list, we are going to make sure we are detecting a vehicle. So we are going to say, if the class ID we are detecting is either a car or a motorbike or a bus or a truck, then we are going to continue. And if not, we are going to neglect the bounding box, the detection we just got. And the indexes we are interested in are 0, 1, 2 for car, so we are just going to put 2, then 3 for motorbike, 4, 5 for bus, and then 6, 7 for truck, right? We don't really have any motorbike in this video, I know for sure because I already watched the video, but nevertheless, in order to make this more generic, I'm just going to add motorbike as well. So if our class ID is within our vehicles, then we are going to continue. And I'm going to create another variable, which is detections underscore, and this is where I'm going to save all the bounding boxes of all the vehicles we are going to detect in this video. So I'm going to do something like this. If we have detected a vehicle, then I'm going to append the bounding box and the confidence score to this new variable. And please mind that I'm not saving the class ID. From now on, it's not really that important. We are not really going to care about the specific class ID we have detected. From now on, the only thing we care about our detections is that they are vehicles, right? And we don't really care to know exactly what type of vehicles. So this is the new variable in which I'm going to be working from now on in this tutorial, in this process. And now let's continue. And now it's the time in which we are going to implement the object tracking. Remember, we were going to work with object tracking in this tutorial, and now it's the time where we are going to implement this tracking functionality into this project. And before we do so, let me give you a very quick explanation regarding why exactly we are using this tracking, why exactly we are going to implement this object tracking. And basically, every time we solve a problem, every time we solve not only a computer vision problem, but any type of problem, you need to use absolutely all the information you have available regarding that problem. And in this case, we are going to be tracking license plates which are moving through a video, right? We are going to be detecting license plates on individual frames, and these license plates are objects which are moving through a video. So if we are able to track these license plates through all this video, we will have more information, and this additional information is going to be super valuable in order to build a more robust solution. So that's pretty much the reason why we are going to implement this object tracking. And we are going to be tracking, we're not going to be tracking the license plates themselves, but we are going to be tracking the cars, the vehicles. And I'm going to show you exactly why later on. So this is what we are going to do. We are going to work with this repository. Remember, I showed you this repository when we were starting with this tutorial. And the first thing you should do is cloning this repository into your local drive, into your local directory. You need to clone this repository into the directory, into the root directory of your PyCharm project. So in my case, this is the root directory of my PyCharm project. This is where I have all my Python scripts, and this is where I have all my files related to this project. And you can clone this repository in one of these two ways. Let me show you. One of the ways is opening a terminal and typing something like git clone and the repository URL. So I'm going to click here, I'm going to copy the repository URL, and then I'm going to paste the repository URL here, and then the only thing you will need to do is to press enter, right? And that's exactly how you can clone this repository into your local computer. But there's another way in which you can do it, and actually this is a much more simple way, and maybe you prefer to do it like this, which is just downloading the entire repository as a zip file. And once you have downloaded this file, this zip file, the only thing you need to do is to copy and paste, is to take this directory, this sort master directory, into your local directory, right? That's the only thing you need to do, is to drag and drop this directory into your local computer, and that's it. And please mind that this directory is called sort master, but you will need to edit the name, you will need to rename this directory into sort, right? You can see here in my computer, this is my directory, this is called sort. If I open this directory, you can see these are all the files which are in this repository. So basically, remember to rename this directory into sort. It's going to be called sort master, but you need to rename this directory into sort. That's very important. Otherwise, you will have some issues, possibly you will have some issues with the next steps in this tutorial. So let's go back to PyCharm. This is the repository you need to clone into your local directory, and remember to call the directory containing this repository, remember to call this directory sort. Now let's take it back to PyCharm, and what I'm going to do now is just importing sort. Let's call from sort.sort. I'm going to import everything. We are going to import absolutely everything from this library, and then I'm going to call an object. I'm going to create a new object which is called mod tracker, and this is going to be equal to sort. Right? This is the object tracker we are going to use in order to track all the vehicles in our video. And now let's get back here, and what I'm going to do now is just calling modTracker.update, and I'm going to input a numpy array of this list we have created containing all the vehicles in our video, right? And this is going to be something like track IDs, right? So track IDs is going to contain all the bounding boxes of all the vehicles we have detected in this frame, but with the tracking information, right? It's going to add an additional column, an additional field, which is going to be the car ID, the vehicle ID for each one of the cars we are going to detect. And this vehicle ID or this car ID is going to represent that specific car through all the video, right? So let's continue. So now we are tracking all of our objects, all of our cars, and now it's the time to detect the license plates, right? So far the only thing we have detected is the cars in the video, but now it's the time to detect the license plates, and in order to do so we are going to use this detector over here, which is license plate detector, and we're going to do it exactly the same way as we have detected the cars, right? I'm just going to copy and paste this sentence, and I'm going to replace Coco model by license plate detector, right? And this way we are going to be detecting all the license plates. I'm going to call this object license plates, and then I'm going to iterate in all the license plates we detect within this frame, and in order to do so I'm going to call for license plate in license plates dot boxes dot data dot to list, and that's pretty much all. And then let's ungrab all the information we got from this license plate exactly as we did before. So this is going to be something like x1, y1, x2, y2, score, and class ID. This is going to be license plate. Okay, then we will need to assign each license plate to a given car, right? Because we have detected all the cars in every frame and all the license plates in every frame, but so far we have cars and we have license plates, and we don't really know which license plates belong to which car, right? And we know for sure that every single license plate will be on one of our cars, but we don't really know which one goes with which one, right? So now in this step is where we are going to assign a car to absolutely every single one of our license plates, right? And in order to do so, we are going to use one of the functions in our util file. We are going to use this function, which is getCar. This function receives a license plate and receives this object we have over here, receives all this object with all the tracking information for all the cars in that specific frame, and it returns a tuple containing the vehicle coordinates and its ID, right? So we are going to call this function getCar, and this function is going to return the car this license plate belongs to, right? This is what we're going to do. I'm going to import from util import getCar, and now I'm going to call getCar. I'm going to input the license plate, and I'm going to input this object, which is track IDs. Remember, this object contains all the bounding boxes and also all the tracking related information, right? That's very important. And the return will be the coordinates of the car this license plate belongs to. So this is going to be something like X car 1, Y car 1, X car 2, Y car 2, and then the car ID for this car, right? Remember, every single car in our video will have an ID. It will have a very unique ID, which is going to identify the car through all the frames in the video. That's very important. And also please mind that this function is completely empty for now, right? This function is only returning some very dummy values, and this function is completely and 100% empty, and this is exactly what we will need to implement in the next step in this project, right? Once we are completely ready, once we have completed this pipeline, then at the end of this pipeline, at the end of this process, then we are going back here to util.py, to this file, to the util.py file, and we are going to implement this function, right? So now we have assigned the license plate to a very specific car. Now we know what's the car this license plate belongs to, and now we can continue with the next step, which is cropping the license plate. And this is how we're going to do. We are going to call frame, and then we're going to input the license plate coordinates, which is int y1, int y2, and then int x1 and int x2, right? So this is the license plate crop, and that's pretty much all we need to do in this step of this process. And now let's continue to the next step, which is processing this license plate. Right now we are going to apply some image processing filter to this crop we have over here in order to further process this image, so we improve this image so it's much simpler for the OCR technology, for EasyOCR, to read the content from the license plate. Now it's time to apply some image processing filters to this crop. And specifically the filters we are going to apply are a grayscale conversion, and then we are going to apply a threshold. So let's see how we can do that. I'm going to call cv2.cvt_color. I'm going to input the license plate crop, and then I'm going to call cv2color BGR to gray. And this is going to be license plate gray. License plate crop gray, right? Now we have converted the license plate crop into a grayscale image, and now the only thing we need to do is to call cv2 threshold. We are going to input this grayscale image. Then it's the threshold, which I'm going to set in 64, and then it's the value at which we are going to take all the pixels which are lower than the given threshold, right? Which is 255. And then I say the value at which we are going to take all the pixels which are lower than the threshold, because we are going to use the inverse threshold. We are going to use the trace binary inverse type of threshold, and this type of threshold is going to take all the pixels which are lower than 64, is going to take them to 255, and all the pixels which are higher than 64 is going to take them to 0, right? That's exactly how this threshold works. And if you want more details on how this function works, I invite you to take a look at one of my previous videos where I show you an entire course of OpenCV with Python, and one of the lessons in this course is exactly about thresholding, right? It's exactly about this function. So I'm going to be posting a link to this course somewhere in this video, so you are welcome to take a look at this course and at this lesson particularly to get more details on how thresholding works. Now let's continue. This is going to be equal to a variable which we are not going to use in this tutorial, so it doesn't really matter. And then I'm going to call the output license plate crop threshold, right? So this is going to be the thresholded image, and this is exactly the image we are going to input into our OCR technology, into our EasyOCR algorithm. And in order to be more clear about the difference between these two images, I am going to visualize these images super quickly so you see exactly how they look like. I'm going to call imShow, and I'm going to input this image, which is license plate crop. I'm going to call this window crop, I'm going to call it original crop, so it's more clear. This is the image we are cropping from the frame, and then I'm going to call CB2 image show again, and in this case I'm going to be plotting the threshold, and I'm going to input this other variable. And then the only thing I'm going to do is to call CB2 weight key. And let's take a look at these two images super quickly so you see exactly how they look like. And this is what we got, and you can see that this is the frame, this is the crop we are making from the frame. So this is the license plate, and this is exactly how we are cropping this license plate from the frame. And this is the thresholded image, right? You can see that in this image absolutely every single pixel is either white or black, and this type of image, this thresholded image, will make it much simpler to EasyOCR, to our OCR technology, to read the content from this image, right? This is the image we are going to use in order to read the license plate number, because this is going to make it much simpler to EasyOCR. So it's going to be much simpler to our OCR to read the license plate. So that was like a very quick way to show you how these two images look like. And now let's continue. Now it's the time to read the license plate number. We are almost there. We have almost completed this process, and this is how we're going to do. Now we're going to call another function which is defined in util.py, and this function is read license plate. And you can see that this function is not implemented either. This function is completely empty. We are returning some dummy values, and this is another function which we are going to implement later on. We are going to implement after we are happy with this process. Once we are completely and absolutely happy with this pipeline, then we are going to move to util.py and we are going to implement this function as well. But for now, we are just going to use this function. So I'm going to import it as well. No, this is not the function name. Read license plate, something like this. And now let's see how we can use this function. I'm going to call util.readLicensePlate, and this is going to return two values. Let's look at the function documentation to see exactly what are the values which are going to be returned here. We are going to, it's going to return a tuple containing the formatted license plate text and its confidence score. So this is going to be something like license plate text and then license plate text confidence score, right? These are the two values we are going to be getting from here, and the input should be the license plate crop. In our case, we are going to input the thresholded crop, right? This thresholded version of our crop, and that's pretty much all, right? Remember, we are just completing the pipeline, the most generic process. Then we are going to get back here in order to implement this function and this other function, right? And now let's continue. Now the only thing we need to do is to write the results. We are almost there. We have almost completed this process, and now obviously if we want to take these results and we want to visualize these results, or if we want to analyze these results, whatever thing we want to do with these results, we obviously need to write these results to our local computer. So this is how we are going to do. In order to write these results, we are going to use another function which is also defined in this util.py file, and it's called write_csv. And this function is implemented. This function is 100% and fully implemented. You can see that this is all the code we have for this function, and everything is just ready, and we can just use this function as it is. Remember, in this tutorial and in basically all my tutorials, we always focus on the computer vision part of the problems. So writing this CSV file is not really that important from a computer vision point of view, so that's why we are not really going to implement this function live in this video, but this is already implemented and we're just going to use it. So let's see what this function does, and it says writes the results to a CSV file, and it receives two arguments, which are the results, which is a dictionary containing the results, and then it also receives a path to the CSV file we are going to produce, and this is going to be the path in which we are going to write this CSV file, right? It's the path in which we are going to save the CSV file we are going to produce. So if we are going to input a dictionary, then we need to produce a dictionary in order to input into this function, right? We need to take all of our information and we need to put all of this information into a dictionary, right? That's very, very important. So that's what we are going to do now, because for now the only thing we have done is just computing all the information, but we have not saved this information into any type of dictionary or anything like that. So I'm going to create a new variable which is called results. And results is going to be a dictionary. And then this is where I'm going to save all the information. And this is how we are going to do. The first key in this dictionary will be the frame number, right? We are going to save all the information and we are going to start with the frame number. We are going to have a different key for absolutely every single frame in our video. And then for absolutely every single frame, we are going to save all the information which is related to all the cars we are detecting, and most importantly, to all the license plates, right? So then I'm going back to the end of this pipeline here, and I'm going to say something like, I'm going to make a very quick edit first, which is going back to this function, and instead of returning 2 nons, I'm going to be returning 2 zeros, right? Because we are going to reserve this other output, we are going to reserve the non output for those times in which we are going to find an error or we are going to have any type of issues reading the license plate. And this is going to be much more clear later on once we are implementing this function. But for now, just bear with me that it's much more convenient to return some dummy values which are different than none. So let's get back here, and this is where we're going to say if license plate text is not none, we are going to save all the information about this license plate in this dictionary we have just created. So we are going to take this variable over here, which is results for that specific frame number, and we're going to create a new entry with all the information for the license plate we have detected, right? And this is how we're going to do. I'm just going to write it first and I'm going to explain it once it's done, once I'm completed, and this is what I'm going to do. I'm going to say the next key is the car ID, right? This is going to be results, frame number, car ID, and then for this car I'm going to create a new dictionary which is going to have 2 keys. One of them is car and the other one is license plate. For car we are going to have another dictionary which is the bounding box, and that's it, right? And for the license plate, we are going to have another dictionary, which is something like box, the bounding box. Then also the text we have detected, then the confidence value for the bounding box, and then the confidence value for the text, right? Okay, and that's pretty much all. So I'm just going to format this a little nicer, and that's pretty much all. Now let's see what exactly we need to input in each one of these fields. Okay, so basically for the car bounding box, we are going to input these values over here, which are the car bounding box, right? These are the coordinates of the bounding box of this specific car. And then for the license plate bounding box, we are going to input these values, which are the coordinates for the bounding box of this license plate. And then for the text, we are going to input this value, which is license plate text. For bounding box score, we are going to input this value, which is the score in which we have detected this license plate. Then for text score, we are going to input this variable, which is license plate text score. And by doing so, we don't have any errors and everything is okay. So for every single frame number, we are going to be saving all the information which is related to each one of our cars. And all the information for each car will be the information of that specific car, where the car is located, and then all the information about the license plate which we have detected in that specific car, right? And for the license plate, we are going to save all the information we have, right? And we're going to save all this information only in those cases in which we have detected a license plate, and every time we have successfully read the license plate number from this license plate, so this object is not known, we are going to be saving all this information into this dictionary only in that case, only when we have detected a license plate and when we have read its license plate number, right? And please notice the structure I have built for this information, for this dictionary, because remember, every time we detect a license plate, it will not be floating around in space completely isolated. No, that will never happen. Every time we detect a license plate, it will be on a given car, and this car will be on a given frame, right? So this is exactly why this structure I have decided for this dictionary. And once we have created all this information, the only thing we need to do is to call. I'm going to import this function as well. I'm going to input, the name was something like write_csv. So let's import write_csv as well. And something is going on because we are not really using this import we have over here. So if I scroll down, I see I'm not really importing the function itself. I think there we should be okay. Okay, so now let's go back here, and I'm going to call this function, which is write_csv, and I need to input the dictionary. So I'm going to input results, and I'm also going to input where I want this CSV file to be saved. And I'm going to save all this information into a CSV file called test.csv. So what I'm going to do now is I'm going to execute this pipeline, I'm going to execute this process as it is, and then we are going to take a look at this file, and then we are going to continue, right? Then we are going to see if the file we are going to create, it makes sense, right? So I'm just going to press play. Okay, the execution is now completed, and now if I go to my local directory, to the directory of this PyCharm project, this is test.csv, so this is the file we have just created, and if I open this file, you can see that this is all the information we have saved and we have extracted from this video, right? Remember, we are processing only the first 10 frames, we are still processing only the first 10 frames, so this is all the information we have extracted so far. And please remember, we are just computing some dummy values from some of our functions, so this is not really all the information. This is all the information we have computed so far. But other than all of these zeros over here and these zeros over here, you can see everything looks pretty well, right? We are just producing an entire CSV file with all the information we have computed from this video. We are almost there, and actually we are there. We are ready. We have completed this pipeline. We have completed this process. We are almost there. The only thing we need to do now is going back to util.py, because we need to implement these two functions, get car and read license plate. And once these functions are implemented, then we are going to be producing a real file, right? We are going to be producing a file with the entire information here and here, right? We are going to be producing the real license plate number and the real license plate score, and also the car bounding box and the car ID for absolutely every single license plate in absolutely every single frame in which we have a detection, right? So we are almost there. I am super excited. And now let's continue to the util.py file so we can implement these functions. And let's start with get car. Remember, from the main.py pipeline, we were using this function, which is getCar, in order to assign which car each license plate belongs to, right? We had many cars and many license plates, and for each one of these license plates, we want to know what's the car this license plate belongs to. So this is exactly where we were using this function, getCar. And now let's see exactly how we are going to implement the function. And in order to do so, I'm going to show you a few pictures. This is a random frame from our video, right? You can see that this is a frame, we have many cars, and this is only a frame from the video. Once we have detected all the cars, we are going to have a situation like this. We are going to have many detections, because at every single frame we are going to have many cars. I don't know how many cars we have in this picture, but they are many. They are something like, I don't know, 20, 30, 50, maybe 60 cars. They are many cars. So for every single frame, we are going to have many detections, which are going to be our cars. We are going to have many bounding boxes for all of our cars. And also at every single frame, we are going to have all of our license plates. But please focus, please mind that we are only going to have maybe 1 or 2 or 3 license plates for every single frame, right? So we are going to have many cars, but only a few license plates. And the idea is to know which car this license plate belongs to, and the way we are going to know that is by looking at all of these bounding boxes, by looking at all of these cars, and by finding the car which contains the license plate, right? By finding the bounding box of the car which contains the bounding box of this license plate, right? That's the way we are going to find what's the car which belongs to this license plate. So that's exactly the idea of what we are going to be implementing in this function. Now let's see exactly how we can do that. The first thing I'm going to do is unwrap all the information in license plate. So in order to do so, I'm going to do something like this, because this is exactly the same object, license plate. So I'm just going to do this, okay? Then I'm going to iterate in all the cars we have over here. I'm going to say for, let's say for J in len vehicle track IDs, we are going to be iterating in all the cars we have detected. And remember, this is the entire information. This is the bounding box, and this is also the car ID. Remember. So now we are going to unwrap all the information for each one of these cars, and this is going to be something like X car 1, Y car 1, X car 2, Y car 2, and car ID. This is exactly the information which is in each one of the elements of this object vehicle trucks IDs. And this is vehicle truck IDs J. Okay. So that's pretty much all. We are iterating in absolutely all the bounding boxes of all the cars we found in this frame. We are iterating in all these bounding boxes. For each one of these bounding boxes, we are going to verify if it contains the license plate, right? That's exactly what we are going to verify, and this is how we're going to do it. We are going to see if x1 is greater, remember x1 is the upper left coordinate of the license plate, if x1 is greater than x car 1 and y1 is greater than y car 1, right? We are verifying that this coordinate over here it's greater than this other coordinate over here. We are trying to verify if we meet this condition, right? And then the other condition we need to meet is if this point we have over here, these coordinates we have over here, they are lesser than this other point we have over here, right? We need to meet these two conditions, and this is exactly how we're going to do it. If x1 greater than x car 1 and y1 greater than y car 1 and x2 lesser than x car 2 and y2 lesser than y car 2, then we have found the bounding box this license plate belongs to. We have found the car on which this license plate is located, right? That's what it means. If we have met all of these conditions, that's what it means. So in this situation, I'm going to define a new variable, which is found it. and found it is going to be false at the beginning, and then it's going to be true in this case. And in this case, we're also going to break the loop, right? And then I'm also going to define another variable, which is going to be car index, and car index will be j. Okay. Now, if found it, then return this value, which is going to be okay. So if we have found the car which contains this license plate, then we are going to return these values, which are the bounding box of the car and also the car ID. And in any other case, we are just going to return this output. And in order to make it more clear that we have not found the car, we are going to return something like this, so it's going to be much more clear. So that's pretty much all. That's it. We have implemented this function, which is get car. And now let's continue. So now let's see if everything works well. Now we should have the right values for all the cars we are detecting, and the only thing I'm going to do is I'm going to execute this script again, and let's see what happens. Okay, I got an error, and I think I know what's the problem. I think we need to iterate in range len vehicle track IDs, and now everything should be okay. Let's try again. Okay, now it's completed, and now let's see the new file we have created, the new test.csv file. And now you can see that we have some values for car ID, and we also have some values for the car bounding box. So we are moving one step at a time, but we are making progress, right? So now let's continue with the util.py file, and now let's move to the next function, which is read license plate. Now it's time to implement this function over here, and something I'm going to do first is I'm going to do an if over here, and I'm going to continue with this pipeline only if car ID is different than -1, right? And now let's continue and let's see how we can implement this function, which is read license plate. And the only thing we need to do is to call EasyOCR, and let's see how we can read the license plate. And let me show you some variables I have defined over here. These variables are going to be super important. Now these variables are going to be super amazingly important. You're going to see exactly why. And then also let me show you this reader we have here. I have already defined, I have already initialized this OCR reader, and you can see that I'm calling EasyOCR, and then I'm calling this method, which is reader. So the only thing we need to do now is calling reader dot read text, and I'm going to input the license plate crop, and this is going to be detections. Then I'm going to iterate for detection in detections, because remember, we could be detecting many different objects, many different text objects in this image. So for each one of these objects, we are going to unwrap these objects first, and this is going to be something like bounding box, text, and score. This is going to be the detection, right? Each one of these detections is going to be something like the bounding box of the text we have detected, then the text we have detected, and then the confidence value for which we have detected this text. And then we are going to convert this text to uppercase, and we are going to remove all the white spaces, right? This is exactly how we are going to do, and this will be equal to text. Okay. And now it's the time in which we are going to use this format, right? Remember when we were starting this tutorial, I told you we were going to focus on this very specific type of license plate, right? We are going to work with this type of license plates. Each license plate is going to have 7 characters. The first 2 characters are going to be letters, then 2 numbers, and then 3 letters. This is the format of absolutely every single license plate we are going to be working with in this tutorial. So we are going to make sure every single text we detect complies with this format. And in order to do so, I have already created a function which is license complies format. This function returns a boolean value which is pretty much the verification of if this license plate complies with the format or not. We are going to be verifying if we have 7 characters, and we're also going to be verifying the first 2 characters are letters, and then the second, the third and the fourth characters are numbers, and then the last 3 characters are letters again, right? This is exactly what we are doing with this function, and this is a very important function we are going to use now. So let me show you exactly how we are going to use this function. If license complies format text, then, and only then, we are going to return the text and the confidence score. We are going to return these 2 values, these 2 variables, which are text and score, right? Only if the text complies with the format we are asking absolutely all the license plates, right? Only in this case we are going to be returning these values, and in any other case we are going to return none, right? This is very, very, very important, and this is going to make our solution way more robust and way, way, way better. And something that makes the solution even better is that we are not going to return the text on itself. We are going to call another function, which is format license, and let me show you exactly what we are going to be doing with this function. I'm going to call format license text, and let me show you let me give you the idea, the high level idea behind this function. Sometimes when we are using an OCR technology, when we are using a library like EasyOCR, sometimes it's very challenging to tell some characters apart. For example, it's very challenging to tell a 5 apart from an S, right? You can see that the letter S and the number 5 are very similar, and it's very, very, very challenging for an OCR to tell the difference between these 2 characters. And we are going to have exactly the same situation for the letter I and the number 1, or for the letter O and the number 0, for example, right? Those are characters which are very, very hard to differentiate. They are very hard to tell apart. So this function I have over here, format license, the only thing it does is goes through all the characters in the license plate in the text, and for each one of these characters it fixes whatever issue we may have with this type of confusions, right? If, for example, we are reading this character over here and OCR, EasyOCR, the OCR technology we are using, it says is the letter S, we know for sure it's not the letter S because we are expecting a number here. So if we have detected the letter S, then we convert this value to the number 5. And the same happens here. If we are reading this value, this character, and we are getting the number 5, we know for sure, for a fact, that that's not the number 5 because we are expecting a letter here. So we are going to convert the number 5 into the letter S. That's exactly the idea, the high level idea of what we are going to be doing with this function. We are going to be going through absolutely all the characters in the license plate, and for each one of these characters we are going to be fixing this type of issues in case we find any type of issues like this. And that's pretty much all. And I invite you to take a look at these 2 functions, to format license and to license complies format, and to take a much closer look and to properly understand exactly how they work, right? That's your homework. That's your homework from this video, so you properly understand how they work. So now let's continue, and now we are returning format license text and score if our license complies with our format, and we are returning none in any other case. And we are done. We are completed. Now we have completed our process. Now let's see what happens. Now I'm going to execute this file again and let's see what happens. I'm going to make a very, very small change. I'm only going to execute it for 10 frames, but I'm going to do it like this. If read, then if frame number greater than 10, then I'm going to break the loop. This is going to be much better. And now let's see what happens. I'm going to execute main again. Okay, it seems I have a typo over here. This is obviously not remove, but this is replace. I got confused because I was removing the white spaces, but this is obviously not the name of the function we want to use here. So now let's see what happens. Okay, now the execution has been completed and now we have produced a new test.csv file, and if I open this file, you can see that we still have all the information related to the car ID and the car bounding box, and now we have all the license plate numbers we have read from the frames from the license plates, and also the confidence score for each one of these license plates. So we made it. We have completed this process. Now we are completed. We are done. So everything is ready. The only thing I'm going to do now is to execute this script, execute this main pipeline for the entire video. So I'm just going to remove this break over here, and that's pretty much all. And now I'm going to press play again, and then I'm going to show you how to visualize this data so everything looks like the video I show you in the intro. So let's see what happens. And now let's go back to PyCharm so I can show you exactly how you can create a visualization as the one I showed you when we were starting this video. And in order to do so, this is where we are going to use these two files, visualize.py and addmissingdata.py. And you're going to find these two files in the GitHub repository of today's tutorial, so you can just go ahead and use them in your project. And before using these two files, let me show you something first. If I go back here to the test.csv file we have created, let me do something. I'm going to filter by car ID, and I'm going to show you all the data, all the information we have extracted for only one of our cars. I'm going to select only the car ID number 3, right? This is only a random car ID in our data. You can see that all the frame numbers we have detected for this car ID are not consecutive. So this means that we have detected the number 0, the frame number 0, then the number 1, then it jumps to the number 4, then it jumps to the number 9, then 12, 13, 14, 15, 16, 17, then 27. So we have many missing frames, right? For some reason we don't have the information for this car ID for many frames which are in between these two, for example, right? We don't have the information for the frame number 2, the frame number 3, or the frame number 5, 6, 7, 8, 10, 11, right? There are many missing frames for this car ID. So that's something that's going on. And remember that we are not saving all the information because we are only saving the information for those license plates for which we have detected the car, the license plate it's on, right? The license plate, the car in where the license plate is located, and also we're only saving the information, the license plates for which we have read a license plate number which complies with our format, right? So we are not saving all the information. There's a lot of information which we are not saving into this CSV file. Remember how the OCR technologies usually work. I mean, they are very good, they perform very good, but in some cases they have errors, they have mistakes. So if in some cases they are not reading a number which complies with this format, then we are not going to be saving the information for those frames. So that's the reason why we have some missing frames over here. That's the first thing I want you to notice. Then another thing which is going to be much more important is take a look what happens with the license plate numbers. Now we have read the license plate numbers in all of these frames, and we have read a number which complies with our format, so everything is okay. But you can see that we have many numbers, right? For example, we have many different values, many different numbers. If I show you the number we have detected in the first frame, it's different than the one we have detected here in the frame number 4, right? And then if I continue scrolling down, you can see that we have also detected other values. For example, here, this is different. And if I continue scrolling down, this is also different. Here we have an N, we have a P. So for every single car ID, we are going to have many different values for the license plate. And this is a huge issue. This is a very important thing we need to solve, because obviously every single car has only one valid value for its license plate. So if we have so many values, if now we have so many values for the license plate, how do we make a decision? How do we know what's the real one, right? What's the real value, the most accurate value for the license plate? How do we make a decision? What's our criteria? That's a huge problem, and this is exactly where the object tracking is involved, because for every single car in the video, because we are going to be tracking the car through all the different frames in the video, for every single car we are going to have the value for the license plate we have detected in that given frame for that car. So if we want to know what's the value for the license plate of a given car through all the frames in the video, the only thing we need to do is to select the license plate we have detected with the highest confidence score, right? You can see this column is the confidence score in which we have detected every single one of these license plates. So the only thing we need to do is to take a look what's the license plate we have detected with the highest confidence, and that's it. That's going to be our criteria to know what's the license plate number of this car, and that's it. That's the way we are going to solve our problem, and that's exactly where the object tracking is involved, and that's exactly why it's so important to track, to implement an object tracking algorithm into this problem, because this is how we are going to solve this problem. This is going to be our criteria to select the license plate number for every single car in this video. So remember, we have these two problems. This is how we are going to solve this problem, and then we still have this other problem, which is that we have some missing frames for every single car, right? This problem actually is not really a big problem, and the only thing it's going to affect is the visualization, right? Because now we are going to take all this information and we are going to visualize this information. So the only thing is going to happen with all these missing frames is that we are just not going to visualize the license plate, and we are not going to visualize the license plate value for that given frame. So let me show you what happens if we create a video from the text file, the CSV file I just showed you. We will have a visualization which looks like this, which will be okay, I guess, but it's like it's not an ideal visualization, right? It's like it's not really pretty, it's not really good looking. This doesn't really look good. Ideally, we would like to have a visualization which is more stable. For every single license plate, we would like to see the license plate on a fixed position through all the different frames in which we are detecting the license plate for that car, right? That's exactly what we would expect, and this is not really good looking. This doesn't really look good, right? So in order to fix this problem, which again is not a huge problem and the only thing it does is to affect the visualization, we are going to use one of these two scripts, which is called add missing data. And the only thing this script does is interpolate all of those frames in which we have not detected a license plate, or in which we are not extracting the information for the license plate. So the only thing we're going to do is interpolate the values for the bounding boxes for the car and the license plate in all of those frames. We are going to interpolate the values. And that's it. For example, in the frame number 41, you can see we have the information for the frame number 40, we have the information in the frame number 42, but we don't have the information in the frame number 41. So the only thing the add missing data.py script does is going to consider the bounding boxes for this frame and the bounding boxes for this frame, and it's going to take the average of all the different coordinates, and by taking the average it's going to compute what is the value of the bounding box in the missing frame. right? And it's going to compute exactly the same process in absolutely all the other missing frames. So that's the way we are going to solve this problem, all the missing frames. Remember, this is only a problem of visualization. This is a matter of visualization. It's not a huge problem. And then once we have fixed that issue, then we can just create the video and that's it. So these two files, I'm going to give you these two files in the GitHub repository of this tutorial. And now let me show you how this works. So the first thing you need to do is to execute add missing data, and you need to change here the path to the file name you are going to interpolate, right? In our case it's test.csv, and then you need to specify what's the file name of the CSV you are going to create with the interpolated data. Let me show you super quickly how this file looks like. I'm going to filter by car ID and I'm going to select the number 3 again. And you can see that in this case we have computed absolutely every single frame, right? We are starting the number 0 just as before, but now we have computed absolutely every single the values for the bounding boxes for absolutely every single frame until the number 65, which is the last frame in which we have detected this car, right? So this is exactly with the data we are creating with add missing data.py. And once we have created this data, this new CSV file, then we go to visualize.py and then we input something like test interpolated.csv. And then we specify what's the file name of the video we are going to create, in this case out.mp4, and the only thing we need to do is to execute this file and then to execute this file, and then after a few minutes we are going to have a video which looks exactly like this. And this is going to be all for today. My name is Felipe, I'm a computer vision engineer, and these are exactly the type of videos and the type of tutorials I make in this channel. If you enjoyed this video, remember to click the like button and also remember to subscribe to my channel. This is going to be all for today, and see you on my next video.